Meta AI has unleashed a breakthrough so profound, it might just redefine the very limits of what we thought AI reasoning was capable of. It's called DeepComp, short for Deep Think with Confidence, and it just achieved an astounding 99.9% accuracy on the AIME 2025 math exam. If you're not familiar, the AIME is one of the toughest problem-solving tests out there, designed to challenge even the most brilliant human minds. What makes this truly remarkable isn't just the near-perfect score, but how it was achieved, using an open-source model, GPTO OSS 120B. That alone is a massive step forward, putting cutting-edge AI power into the hands of many. But the true genius lies in the methodology behind DeepComp, a paradigm shift that moves AI beyond brute force and towards genuine intelligent reasoning. So let's dive into what DeepComp is, how it works, and why it represents such a monumental leap for artificial intelligence. Up until now, the primary way large language models improve their ability to tackle complex problems was through a technique known as parallel thinking. Imagine you pose a difficult question to an AI. Instead of giving one answer, the model would generate a multitude of potential solution paths. Think of it like forming a committee where each member offers a different approach to the same problem. Once all these paths are generated, the system essentially takes a vote, picking the answer that appears most frequently among the various proposed solutions. It's akin to a democratic process, where the majority rules. While this method has certainly yielded impressive results, it comes with two significant drawbacks. Firstly, it quickly hits a wall of diminishing returns. After a certain point, asking the model to explore hundreds or even thousands of different reasoning paths doesn't significantly improve accuracy. In fact, it can sometimes be counterproductive, as faulty or less optimal. Reasoning paths can begin to pollute the vote, potentially leading the AI astray. Secondly, and perhaps more crucially, it's incredibly expensive. Generating all those diverse solution traces consumes an enormous amount of computational resources and tokens. This translates directly into higher processing costs, longer waiting times, and a substantial carbon footprint. It's an inefficient, resource-intensive approach that relies on sheer volume rather than inherent intelligence. DeepComp completely changes this game by introducing a revolutionary concept. It doesn't treat every reasoning path as equally valid. Instead, it carefully scrutinizes the model's internal confidence signals. Essentially, it measures how sure the AI is about each individual step it takes throughout the problem-solving process. Think of it like this. If you're solving a complex math problem yourself, you instinctively know when you're on solid ground and when you're venturing into uncertain territory. That sudden feeling of doubt, that momentary hesitation, is a crucial warning sign that your entire solution might be about to unravel. DeepComp gives the AI a similar intuitive awareness. It empowers the model to identify these stretches of low confidence, and then, crucially, to act on them. This means it can either filter out unreliable reasoning paths after they've been generated, or, even more impressively, stop them dead in their tracks before wasting any more valuable computation. It's about being smart, not just fast or exhaustive. The method by which DeepComp measures this confidence is both sophisticated and remarkably elegant once you break it down. At the most granular level, we have some token confidence. Every single word, number, or symbol that the AI generates comes with an associated probability score. A higher score means the model is more confident in that specific choice. DeepComp then takes these individual probabilities and averages them across the top-ranked options, essentially assessing the stability of the decision being made. Is the model overwhelmingly certain, or are there several almost as likely alternatives vying for attention? Building on this, there's group confidence, which looks at larger clusters of tokens. Instead of focusing on individual elements, it takes a sliding window approach, analyzing chunks of text, perhaps 48 tokens at a time, to smooth out any transient noise and get a broader sense of certainty. Then we have tail confidence, which specifically zooms in on the final section of a reasoning trace. This is particularly important because the answer usually appears in this segment, and it's also where critical mistakes are most likely to occur. Finally, DeepComp also identifies the lowest group confidence, which highlights the weakest link in any given reasoning path, as well as the bottom percentile confidence, which flags the worst sections overall. By combining all these metrics, DeepComp generates a comprehensive health report for every single solution path the model attempts. This multifaceted confidence assessment is what truly enables the AI to reason with a new level of self-awareness. What truly makes this system powerful is how these nuanced confidence signals are put to use. In its offline mode, DeepComp operates after the fact. Once the model has generated multiple reasoning traces, it doesn't just average them. Instead, it intelligently filters out the paths deemed weak or unreliable based on their low confidence scores, allowing only the strongest, most confident solutions to contribute to the final answer. This is like a highly discerning editor, only publishing the most well-reasoned arguments. But the real game changer comes in online mode. Here, the AI can literally stop mid-solution if its internal confidence drops below a predetermined threshold. Imagine an AI beginning to write a long, complex answer, only to realize a few steps in that its reasoning is shaky. With DeepComp, it can abort that specific path immediately, preventing the waste of precious time and computational resources on a solution that was already doomed to fail. This early stopping mechanism is revolutionary. Across various tests, this simple yet profound trick ended up saving anywhere between 43% and an astonishing 85% of tokens. And this wasn't at the expense of accuracy. In fact, accuracy often significantly increased. It's a win-win, smarter, faster, and more precise problem solving. And when they ran the benchmarks, the results were nothing short of jaw-dropping. Take the AIME 2025 exam, for example, using the GPTO OSS 120B model. Its initial, plain old pass at 1 accuracy, meaning its first attempt at a solution, was a respectable 91.8%. With traditional majority voting, where multiple paths are averaged, that climbed to 97%. But with DeepComp, it soared to an incredible 99.9% accuracy, all while saving a staggering 84.7% of tokens. This wasn't a fluke with just one model either. Deepseek 8B, tackling the AIME 2024, saw its baseline accuracy jump from 83% to an impressive 93.3% with DeepComp, cutting token usage by almost 78%. Similarly, Quen 332B leaped from 80.6% to 90.8% accuracy, utilizing 56% fewer tokens across the board. We're not talking about marginal improvements here. These are gains of 5 to 10 percentage points, which is absolutely massive when you're already operating near the theoretical ceiling of what's possible in AI performance. Perhaps one of the most remarkable aspects of DeepComp is its surprisingly light integration requirement. You don't need to retrain the entire model, which is typically a time-consuming and resource-intensive endeavor. There's no need for special, curated datasets, nor does it demand complex hyperparameter tuning. It is, quite literally, a plug-and-play solution for large language models. All that's required is a minor tweak to the log probabilities processor to track sliding window confidence, the addition of an early stop check before the model emits tokens, and passing confidence thresholds through the API. We're talking about maybe 50 lines of code. This means DeepComp could be deployed in production environments with barely a ripple, making its transformative power immediately accessible. It's worth pausing to appreciate the underlying model that helped set this new record. GPTO OSS 120B. This is not just any language model. It's a transformer-based AI with a massive 120 billion parameters, and it has been specifically optimized for mathematical reasoning. Instead of being fed a general diet of text from across the internet, it underwent progressive training through what's known as curriculum learning. This means it started with relatively simple problems and gradually worked its way up to increasingly advanced and complex mathematical challenges. They even went so far as to deliberately introduce wrong answers during its training, allowing the model to learn from mistakes, much like a human student. On top of this, it was exposed to specialized math data, including a wealth of textbooks and problem sets, and its attention mechanisms were fine-tuned to better handle the intricacies of mathematical reasoning. This tailored combination made it far more robust and adept at math than any general-purpose model. And the AIME exam itself deserves its own spotlight. This is far from your standard multiple-choice test. Students are given 3 hours to solve just 15 problems, and every single answer must be an integer between 0 and 999. There's no guessing your way to success here. The problems are meticulously crafted to be tricky and unconventional, pushing students to apply mathematical concepts in novel ways, think laterally, and skillfully navigate around common traps. It's essentially designed to differentiate between merely good math students and the absolute elite, those rare individuals who are on track for the prestigious International Math Olympiad. So, when DeepComp nails a 99.9% accuracy rate on such an exam, it's not merely regurgitating memorized formulas. It is actively demonstrating a level of sophisticated reasoning that stands shoulder to shoulder with the very best human problem solvers. Of course, whenever a technology this powerful and impactful is open-sourced, legitimate concerns about potential misuse inevitably arise. The risks of generating misleading information, producing biased results, or enabling irresponsible applications are very real, and they should not be dismissed lightly. However, Meta's philosophy behind open-sourcing DeepComp and the GPTO OSS 120B model is that it actually enhances the system's transparency and safety. When the code is publicly available, everyone can scrutinize it, identify potential weaknesses, contribute fixes, and collectively work to keep the technology honest and accountable. Instead of being locked away within a single corporate entity, it becomes part of a global, collaborative effort. You can already access DeepComp and GPTO OSS 120B through open repositories, allowing researchers, developers, and enthusiasts to submit improvements, test them in different frameworks, and explore their potential. People are already buzzing about wanting to see this power integrated into local setups like VLM or llama.cpp. This is the inherent advantage of the open source model. It fosters faster innovation, democratizes access to cutting-edge technology, and ultimately builds greater trust within the AI community. Furthermore, DeepComp offers impressive flexibility, allowing users to tailor its operation to their specific needs. If your priority is maximum efficiency and token savings, you can run DeepComp Low, which retains only the top 10% of the most confident reasoning traces. This delivers the highest token savings while still providing a significant boost in accuracy. Conversely, if stability is your primary concern, you can opt for DeepComp High, which keeps 90% of the traces. This still offers substantial gains in performance with virtually no risk of compromising accuracy. This level of customizability means that whether your goal is to drastically cut computational costs or to squeeze out every last bit of performance, DeepComp can be fine-tuned to meet those demands. Ultimately, DeepComp is a resounding proof point that AI doesn't need to rely on brute force or sheer computational power to tackle the most complex challenges. Instead, it can harness its own internal confidence to reason smarter, more efficiently, and with a level of precision that rivals human experts. And with an open-source model like GPTO OSS 120B powering this breakthrough, that kind of sophisticated reasoning is no longer confined to the labs of major corporations. It's now becoming available to everyone, democratizing access to truly advanced artificial intelligence. This is more than just an incremental update. It's a fundamental shift in how we approach AI problem solving, moving us closer to truly intelligent machines that understand their own thought processes. What do you think this means for the future of AI development? Will we see more models adopt this confidence-based reasoning? Let us know your thoughts in the comments below. If you found this dive into DeepComp enlightening, please give this video a like and consider subscribing to stay up to date with the latest breakthroughs in AI. Thanks for watching, and I'll catch you in the next one.